Okay, here are the answers and explanations to homework number 11. Check it out. All right, let me give some explanations to this. Here we go. Problem number 1. You should have written down the formula for area. They gave you the area here, and we want to know how long is one side. So the two things that are in this problem are area and side length. So I want the formula for area and side length. That would be area equals side length squared. And then I'm ready to plug in the numbers. This 160 square feet is the area. So I put that in for A. And I have 160 equals the side length squared. And I would solve that by taking the square root of both sides. And I would find out that S equals the square root of 160, which is about 12.6. So my answer is 12.6, and I need the correct units on it. And the correct units for length is regular units, feet. Problem 2. The area of a square window is 60 square feet. Find the perimeter. Well, I know that there is no formula that goes straight from area to perimeter. So this one's going to take 2 steps. First, I need to figure out, I need to use the area to get the side length. Then I'll use the side length to get the perimeter. So the formula first would be area equals side length squared. And then I would substitute the area in place of the A and say 60 equals side length squared. Then I can take the square root of both and find that the side length is approximately 7.7. Then my other formula will take the side length and help calculate the perimeter. To do that, I would use the formula for perimeter. Perimeter equals 4 times side length. And I would substitute this in for the side length. And I would get perimeter equals 4 times 7.7. And 4 times 7.7 is 30.8. So my perimeter is going to be 30.8. Now, the units for that, perimeter is distance or length. So the units are the same as they are for length, which is just regular units. This would be 30 feet. All right, you might have got something slightly different if you did not round this number to 1/10 like I did. I used 7.7 to help calculate the perimeter. If you did not round the square root of 60 and you just multiplied the answer to that by 4, you would be slightly different. Question 3. Question 3 says, I'm designing a square deck to build behind my house. I have enough space for each side of the deck to be 14 feet long. What will the area be? So again, I have side length and area. I'm going to want to use the formula for area and side length. area equals side length squared. And then I would substitute this in for side length. And I would get area equals 14 squared. Substituting 14 in place of the s. And then I go ahead and solve it. The a is already by itself. I simply need to square 14 and I'm done. The area of this deck will be 196. Now I know that area is measured in square units. So this is going to be square feet, right? Part B wants to know the cost. Well, the total cost is going to equal the number of square feet times the cost per square feet. Or I know from the last problem there are 196 square feet. And I know from this problem that each square foot costs $2.50. So if I multiply 196 times 250, I get the cost, which is $490. Question number 4.
Please pardon the interruption. Jason Bowers, please come to the office.
That's right.
Jason Bowers to the office, please. Thank you.
Question number 4 says, Grace is buying carpet for her family room. Each side of her room is 12 feet. So they've just given me the side length in this problem. How much carpet? Well, this takes a little previous knowledge. You need to know that carpet covers an area. Carpet is not a length. There are carpets that are like runners, but most carpet covers an area. So what this question is really asking you is, what's the area of carpet she needs to buy? My formula then would be the area formula. And since they gave me the side length of the room, I'm going to plug 12 in for S, the side length. And area would equal 12 squared. And again, to solve that, all I need to do is square the 12 and I'm done. The area would be 144. So 144, but I need the units. Area is measured in square units, so that would be 100 square feet. All right, now we start writing numbers with a lower base. So number 5, I can take the 9 and rewrite it as 3 squared. But of course, the exponent needs to come along with it. So I then get 3 squared to the 10th power, which can be rewritten as using the power to a power. I multiply them together, can be rewritten as 3 to the 20th. The next one has 27 to the 8th power. 27 is a perfect cube. It can be rewritten as 3 to the 3rd power. But of course, since the 27 was to the 8th power, the 3 to the 3rd needs to be to the 8th power. Then you can use the power to a power rule and rewrite this by multiplying the exponents together and get 3 to the 24th power. And last up, I have 49, which is a perfect square. It is equal to 7 squared. So I rewrite the 49 as 7 squared, and I make that to the 5th power. And then I can rewrite that using the power to a power rule as 7 to the 10th power. All right, number 8. Number 8, I need to rewrite all of these things so they had the same base. And in this case, the base is going to be 3. I'm going to rewrite each term so it has a base of 3. 27 is a perfect cube. So 27 can be rewritten as 3 cubed. But of course, that 27 was to the 8th power, so I need to rewrite it as 3 cubed to the 8th power. I then use the power to a power rule, multiplying those together, and get 3 to the 24th. On the other side, 3 to the 10th is already simplified. But the 9 can be rewritten as 3 to the 2nd power. Of course, since the 9 was to the 7th, the 3 to the 2nd power needs to be to the 7th. These are the same thing. Then I can use the power to a power rule to write this as 3 to the 14th. Finally, I can multiply these together because they have the same base. By adding the exponents, it would be 3 to the 10 plus 14, or 3 to the 24th. And it turns out that these two amounts are equal to each other. Number 9. All right, the 25 can be rewritten as 5 to the 2nd power. But since 25 was to the 11th, this needs to be to the 11th. And then you can rewrite it as 5 to the, and since this is a power to a power, you multiply them, 5 to the 22nd. The 125 can be rewritten as 5 to the 3rd power, because 125 is a perfect cube. But since it was to the 7th power, you need to rewrite this as to the 7th power. And that gives you 5 to the 21st power. And so, 5 to the 22nd is bigger than 5 to the 21st. Next up, the fractions. The first one is already simplified. Oops. But the other one, you need to use the power to a power rule. 1/6 to the 2nd to the 4th would really just be multiply those together. 1/6 to the 8th. And because we know that the more times you multiply a fraction together, the smaller it gets, 1/6 to the 8th would be bigger because 1/6 to the 13th has been multiplied together more times, making it smaller and smaller and smaller. Last up, let's move this over here. All right, 4 to the 10th can be rewritten as 2 squared, right? 4 is the same as 2 squared, and then that is to the 10th power, which would be 2 to the 20th. 16 can be rewritten as 2 to the 4th power, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. And then that would be to the 2nd power. And then you'd use the power to a power rule and get 2 to the 8th. Oops. I see now I did not finish the first side. So I can also do the 8 to the 4th. 8 to the 4th, well, 8 is a perfect cube, so the 8 can be rewritten as 2 to the 3rd power, and then that is to the 4th power. Now you can use the power to a power rule and get 2 to the 12th power. So this fraction over here is actually 2 to the 20th over 2 to the 12th. Well, now that those have the same base, you can reduce that. When you're dividing terms, you cross them out, or you subtract them. And if I have 20 on top and 12 on the bottom, and I subtract or cross them out, I'm going to have 8 left over on top. That's going to be 2 to the 8th, making these two amounts equal. All right, I'm going to have to do these on the next video. Okay, so I am back to do problems number 12 through 17. All right, the secret to these problems is knowing two things. Well, let's just take it. Here we go. All right, I want to look at the expression x to the 10th. When x to the 10th is replaced with a negative number, like negative 2 to the 10th, we have learned that a negative number multiplied an even amount of times is positive. Every time you have two negative 2's, you have a positive, right? An even number of negatives is actually a positive. When you replace x with a positive numbers are always positive. And when you replace x with 0, 0 to the 10th power would be 0. As opposed to this next one, which has an odd exponent, x to the 17th. So I am multiplying x 17 times. And when you put a negative number in for x, a negative number, an odd number of times multiplied together, is going to leave one negative out, making the whole thing negative. Right? If you have an odd number of negatives, like I wrote 3 down here, but 3 is an odd number, every 2 negatives makes a positive. So if you have an odd one left out, it turns the whole thing negative. However, if you put a positive number in for x, positive numbers stay positive all the time, so that would be positive. And of course, if you put 0 in for x, the whole thing is 0. Let's look at ones that are a little bit tougher. So I have 15x to the 12th. I like to write that as 15 times x to the 12th. I feel like the secret to these is looking at the sign of both terms. Well, 15 is always going to be positive. So I'm going to have a positive times something. Let's start with a negative. When I put a negative in for x, like negative 2 to the 12th, we have learned that a negative number to an even exponent is positive. All right? Again, if you have an even amount of negatives, like 2 of them, an even amount, that turns out to be a positive. And every pair would still be positive. So as long as you have an even amount, you're going to have nice pairs that all turn out to be positive. All right, an even amount of negatives is positive, and this means when you have 15 times x to the 12th, you have a positive times a positive. That's going to be positive. But if I put a negative number in for x, if I put a positive number in for x, Well, positive numbers are always positive. And 15 is always positive. So you have a positive times a positive, and of course that is positive. And last, if you put 0 in for x, you of course would have 0, and 15 times 0 would be 0. Let's look at the next one. Negative 11 times x to the 13th. This one's a tricky one. Okay. If I put a negative number in place of the x, let's see what happens. So, again, look at the sign of the two things you're multiplying together. First, the negative 11. The negative 11 is a negative number. It's always going to be negative. It's negative 11. X to the 13th, though, could be positive, could be negative. If I put a negative number in for x, for example, I put negative 2 in for x, we have learned in class that a negative number to an odd exponent will still be negative. Any negative number to the 13th power, since it's an odd exponent, will still be negative. So what I end up with here is a negative times a negative, which of course equals a positive. How about if I put a positive number in for x? A positive number. Well, negative 11 is going to be negative, no matter what. I'm just looking at the sign of the two things I multiply together. The sign of this is always going to be negative. But when I put a positive number in for x, like say 2 to the 13th power, positive numbers always stay positive. So now I end up with a negative number times a positive number, and a negative times a positive would be negative. And last up, of course, when I put 0 in for x, I end up with negative 11 times 0, which is 0. Two more. Number 16. I have 10 times x to the 21st. All right, let's look at the sign of the two things that are being multiplied together. The sign of 10 is positive. 10 is a positive number. What's the sign of x to the 21st? Well, that depends what you put in for x. If you put a negative number in for x, any negative number to an odd exponent will still be negative. All right? Because if you have an odd number of negatives, like 3 of them, every pair ends up being positive. So if you have an odd number, you have one left out. And that one guy left out turns the whole thing negative. An odd number of negatives is a negative. So what I end up with here then is a positive times a negative, which is negative. What if I put a positive number in place of the x? Well, the 10 is going to be positive, and if I put a positive number in for x, that's going to be positive as well. And a positive times a positive is a positive. And of course, if I put 0 in for x, I end up with 10 times 0 to the 21st, which is just 0. 10 times 0 is 0. And I get 0. Last question. negative 3 times x to the 30th. All right, again, look at the sign of the two things you're multiplying together. The sign of negative 3 is negative. What's the sign of x to the 30th? Well, that might depend on what you put in for x. If you put a negative number in for x, like say negative 2, a negative number to an even exponent turns positive. And so you end up with a negative times a positive, which is a negative result. If you put a negative number in place of the x, you're going to end up with a negative times a positive, which is going to be negative. How about if you put a positive number in place of the x? If I put a positive number in place of the x, like 2, positive numbers, of course, stay positive. So this number is going to be negative, because negative 3 is negative. But 2 to the 30th is going to be positive, and a negative times a positive is negative. And last up, if you put 0 in for x, this turns out to be 0, and you'd have negative 3 times 0, which is 0. All right, hope that helps.